Hi, my name is Medhat El Masri. Today I'm going to talk to you about building a serverless Azure Functions Web API app with entity framework migrations and dependency injection using Visual Studio Code on Windows. Now, the source code for all of this, you can find it at this location, and I've also written an article about this, and you can find the article at this location. So let's get started. Support for dependency injection in Azure Functions was announced at Build 2019. This opens up new opportunities for building better architected C# applications with serverless Azure Functions. In this tutorial, I will demonstrate how to build a Web API application using Azure Functions. The application we will build together will use Entity Framework core migrations and dependency injection. Instead of using Visual Studio 2019, we will build our application using the lightweight Visual Studio Code editor. You need to install the Azure Functions extension for Visual Studio Code before proceeding with this tutorial. Now, I have already installed it, as you can see right here. But if you haven't installed it, you need to install this extension. Another thing you need to install is the Azure Functions Core Tools, and that's done using the npm package installer. The actual install is this here. I have done that already, so I don't really need to do it. I suggest you start by creating a folder on your hard drive for the application that we're going to be building, and I did one already. I called it AZ Functions. Now, going back to Visual Studio Code, when you install the Azure Functions extension, you will notice that you have this Azure symbol here. So let's click on it. When you click on it, you will notice that you've got a Functions tab right here. And this is the subscription that you have. If you don't see this tab, then you will be asked to log in to Azure. So you would log in at that point with your username and your password. Also, if you have multiple subscriptions, you'll see the list of subscriptions down here under this one account. Now I'm going to click on this one subscription that I have, and I'll click on this tab here, the Create New Project tab right here. It asks me for the folder that will contain my function project. So I'm going to click on Browse here and navigate to the folder that's going to hold my application. I'm going to put it right here. The next thing it's going to ask you is the language that you want to use. And I'm going to use C#. So I'm going to click on C#. After that, it asks me for the type of template that I want to use. And the template I'm going to use is the HTTP trigger. It asks me next for the function name that I want to use. Now I'm going to change this a little bit. I'm going to call it HTTP Web API. So I'll change the name to HTTP Web API. And hit enter. Next, it's going to ask me for the namespace that I want to use. I'm going to simply put in snoopy.function. And hit enter. It then asks me about the access rights. I'm going to choose anonymous. The next question is, do you want to open it in the current window? And I'm going to say yes. So you can see down here, it is creating for me the project. When it's done creating the project, you can see a message down here, and it says, do you want me to restore the packages? And I'm going to say, of course. So I'll click on the restore button. At this point, I can run my application and see what it does. So I'm going to hit Control F5 on my keyboard, and that should run my application. The application is going to run locally in an emulator. Now the URL of that emulator will show up in a moment, but you'll get a message saying, do you allow the system to open up a port number? And I'm going to say yes, allow access. And here is the URL. If I want to go directly to that URL, I could hit Control and click at the same time. As you can see in this message here, Control plus click. And it should take me into a browser at that location. And here it is. Let's make this a little bit bigger. It says, please pass a name on the query string or in the request body. I'm going to pass a name in the query string, so I'm going to enter question mark, name equals to Superman. Here. And when I do that, it's going to come back to me and say, hello, Superman. So this is what this very basic application does. In this tutorial, we're going to create a web API serverless Azure function that retrieves the information about a student. And the student model is going to look like this. We have student ID, first name, last name, and school. We will be using Entity Framework and SQL Server. And the SQL Server that we're going to be using is SQL Server on Azure. So I need to install some packages. These are the packages that I need to install in my application. We need to install 1, 2, 3, 4, 5, 6 packages. So I'm going to go into a DOS prompt at the location of my application and install all of these packages one by one. So right here I'm going to type in CMD to take me to a command prompt. And here I will install these packages one by one. In fact, I can copy all of these and paste them in this window and let it all install. It is done installing all of those 6 packages. I'm going to return to my Visual Studio Code application, and I want to create a student model. So I'm going to create a new file at this point here, and I'm going to call it student.cs. And in the student.cs file, I'll add my student model. So this is the code I entered here. And of course I need to resolve this namespace. So I'm going to hit Control dot and select using component model dot data annotation. Now in my application, I've got a class called HTTP Web API, and this is the class that created for us this Hello World kind of application. I want to add a different function. So there's a function here called HTTP Web API, and I'm going to add another function name. Now the class is declared as being a static class. I'm going to remove the word static from here. So the signature of my class will be simply public class HTTP Web API. Of course, when you're working with Entity Framework Core, you need to have a DBContext class. So my next step is to create a DBContext class. So I'm going to come here and add a new file, and I'm going to call it the school DBContext. And in this school DBContext, I'm going to add some code. And this is really standard code for creating a DBContext class. My school DBContext class is called school DBContext, and it inherits from the DBContext class. And it's got one entity, which is a collection of student objects. So the property is DBSetStudent, and it's going to be given the name students. This is the constructor, and the constructor takes the options as an argument and passes it to the base class. And this onModelCreating method is used here for creating 4 sample items of data, one for Jane, one for John, one for Pamela, and one for Peter. So I'm going to resolve all these namespaces here. To register a service like School DBContext, let's create a class file named startup.cs that implements function startup. So I'm going to stop my app now and create a startup.cs file right in the root of my application. And in that file, I'm going to put some code. Let's resolve all of these namespaces. Let's see what this does. This has a configure method. It grabs an environment variable and it specifies that the application is going to be using SQL Server. So SQL Server will be using a database that's based on this connection string, and we're adding the DB context here. And also we're adding the HTTP client service here. Now, as I said earlier, that in build 2019, it was announced that Azure Functions, they support dependency injection. So we want to add some dependency injection into our main Azure Function class. So let's go back now to our main Azure Function class, which is this one here. And I'm going to inject 2 objects, the HTTP client object and my database context class. So I'm going to add these instance variables here. The first one is HTTP client and the second one is school DB context. Let me resolve this namespace. And I'm going to add the constructor and inject these objects inside of the constructor as arguments. So this is what the end result will look like. And this is essentially dependency injection. You can see here that these 2 objects are being passed as arguments in the constructor, and here we're assigning the instance variables with the values that are being passed in the constructor as arguments. We want to use the design time DB context creation. Since we are not using something like ASP.NET directly here, but implementing the Azure Functions configure method, Entity Framework will not automatically discover the desired DB context. Therefore, we need to implement an iDesignTime DBContext Factory class to drive the tooling. So let's create a class file named schoolcontextfactory.cs right here. The code for this class is as follows. Let me resolve these namespaces first. Now, this class inherits from iDesignTime DBContext Factory based on school DBContext. And here we have a method called createDBContext that takes some arguments and returns a school DBContext class. We instantiate a DBContext options builder class based on school DBContext. It returns an options builder object, and with this options builder object we specify that we're going to be using SQL Server, and we're going to grab the connection string from the environment. In fact, there's going to be an environment variable called cstring that contains the connection string. And with that, we're going to return a school DBContext object. As I said earlier, we're going to be using entity framework migrations. Now, entity framework migrations expects the main DLL file to be in the root project directory. The way Azure Functions work is that the main DLL is placed under this directory, bin debug netcore app 2.1 bin folder. And this is not where entity framework expects the DLL to be. It expects it to be in the root of my application. Therefore, I'm going to add some markup that we're going to put inside of the CS_proj file so that a copy of that DLL is made in the root of my application. So let's go to the CS_proj file, and I'm going to add something at the bottom here that does what I wanted to do. And you can see the code for this is to copy the project name.dll to the target root directory. So this is a post build event, and this is what it looks like. So this should make for me a copy of the DLL in the root of my application. Go ahead and create a SQL Server database in Azure. And once you've done that, you need to grab the connection string. So here's my connection string. You have to put the name of your database server here instead of the X's. You need to put your username instead of the Y's, and you need to put your password instead of the Z's. After you've done that, you need to set an environment variable inside of your operating system. I'm using Windows 10, so this is the command for doing that. So I'm going to set this environment variable on my computer. I do that by hitting Control backtack and getting into this command prompt in Visual Studio Code, and I'm going to paste my connection string right here. So having done that, I now have that in my environment. If I type in echo and cstring, I should see my environment variable. The next step is to apply entity framework migrations. So in that same terminal window inside of Visual Studio Code, I'm going to make sure that my application builds. So I'm going to type in .NET build and hit enter. The next step is to add a migration. So I'm going to execute this command that adds for me a migration that I'm just going to call M1. So the command is .NET EF Migrations add M1. Hit enter. And that seemed to have worked because I get this command done to undo this action, use EF Migrations remove. What happened here is that we got a folder created for us. That's the migrations folder, and in that migrations folder we have a file with the name of the migration, which I called M1, and a timestamp before it. If you open up this file, these are the commands that create the artifacts in the database, which includes the students table, the primary key, and this part here produces for us the sample data, and the down method rolls back any of the artifacts that were created in the database. At this point, the database has not been created on the server. the next step is going to create for us the database in the server and add the sample data. And the command for doing that is this: .NET EF database update. Let's hit enter. This may take a while. I actually stopped the video and restarted it. But if all goes well, you should get this message here. Now, one of the things that could go wrong is that you don't have the proper connection string. And another thing also is that inside of Azure, you have to allow for your client IP address. In this case, everything seems to be okay, and our database has been created and the migrations have been applied. And at this point, you can rest assured that you've got sample data too. Let us now create an endpoint in our Azure Functions class that returns all the students as an API. So we want to add a method to our HTTP Web API class that is essentially another Azure function. So let's go over to our Web API Azure class, which is this one. And we're going to add a new function here. So there's going to be another function here that we're going to pop underneath the previous function that is called run, but we're going to have a different name, and we'll add a dedicated function that returns the data in the database. And this is the code for that. The function name, we're going to call it getStudents, and this is our getStudents function. It is based on the HTTP trigger template, and we're going to use the get method, and the route would be simply students. So to hit this, you have to enter /API/students. This is log information here. Here we're injecting the context class. Now we need to resolve something because there's a squiggly under order by, and if you hit Control dot, you'll discover that what it's missing is simply link. So I'm going to resolve that. So this returns a student array, and then we're just gonna return back the students array, and you get back an iAction result. We're pretty much done. There's only one problem, and the problem is that when we run this application, it's going to grab an environment variable that is not coming from the operating system. It's going to be coming from the context that it's running under. So we need to set an environment variable someplace else, and the place to do that is to go into this file here called local settings.json, and we'll add that environment variable right in here. So the environment variable is going to look like this. It's just another setting, a name value pair that goes into the JSON file. So that's what I'm going to do. I'm going to copy this and then come in here, put a comma, and basically put in my connection string. So the key would be just simply C string, and the value is the connection string that you already have. So I've done that. I'm going to close my local settings.json, and at this point I should be able to run my application and get some data. So I'm going to hit Control F5 and see what happens. So now we have this new endpoint here, API students. Let's see if this is going to work. So I'm going to hit Control, click on this, and there we go. We're getting our data. So this demonstrates to us that another way of creating a web API, in addition to the ASP.NET way of doing it, is to create it using an Azure function. And using an Azure function is, of course, much cheaper. So in conclusion, it is easy to create Azure functions with the very flexible VS Code editor. Also, creating an API with Azure functions is much cheaper than doing it with ASP.NET Core web applications, because you pay a fraction of a cent for every request, and the app does not need to be constantly running. I hope you liked my video, and if you did like it, please give me a like in YouTube. Thank you, and see you next time.